Today we are going to be discussing the automatic response detection elements in DX. Automatic response detections automatically identify and tabulate important responses from all signals in one or more files. They can be used to eliminate the need to review all signals for important responses, saving aeromechanics engineers lots of time. We will start with the largest response detection. The largest response detection element searches the entire signal for the largest responses. Very straightforward. The grid response detection does the same, but instead of taking the entire signal into consideration, it splits up each into an evenly spaced grid and collects one peak per grid space. So if I set my parameter bins to 5 and my frequency bins to 5, I will get 25 peaks collected per channel. The EO response detection element searches for important responses based on engine orders that can be selected by the user. And we'll hop into the settings in just a moment. To demonstrate the difference between these, I'm going to go ahead and hop into the viewer. I've used this design right here to process my data already, and have taken the liberty of making a few plots already. The automatic response detections show up here on the left side of the tree under a automatic response detections section if multiple response detections have been made. I will first add the largest response detection, which I have set to collect the 10 largest peaks. As you can see here, it's going to highlight those peaks on the Campbell diagram. I can zoom in and I can count 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there's 2 right here, 10 there. Yep. And see, I have 10 here. And you can see that this has done this now for every channel in my process. So as an example, here is another one with the largest response detection, another with the largest response detection, another one here, and another one here. I'll return back to my first one to show the grid response detection. I have a 10 by 10 grid selected here. So you will find a point in regular intervals on both the X and the Y axis divided into grid by 10. So there should be 100 points here on this Campbell diagram. And again, here I have my engine order response detection, which I have selected to collect the top 5 largest peaks on engine order 48, engine order 1, and engine order 3. All of the results from the automatic response detections can be viewed in a table. So if I navigate to a blank page here and I click and drag my largest response detection onto a blank plot space, it will create this table where I can see all of my information here. As you can see, lots of information is available on each one of the points, including different limits information if a limits file is loaded. I can filter by channel name here, and as you can see, we have our 10 largest peaks per channel. I can search by frequency or magnitude and set different filters in different orders. And of course, all of this can be exported as a CSV. And the exporters also are available in the designer here. You can see that I can enable the largest response detection exporter. The thing that's special about using this in the designer is that these files will be concatenated with new data points or new files that are processed. So if I do 10 runs at different operating conditions, I can process all 10 files through this same design and be left with one CSV file that includes all of the most important responses to me in that file. Each one of the response detection elements has a number of settings available, including parameter range here, peaks to collect. I have, again, set this one to 10, an EO tolerance, magnitude threshold, and a minimum magnitude ratio for applying a limit. Additionally, all of the response detection elements will include this mode ID area. When a limits file is loaded, this will perform an algorithm based on the weighing set to identify each point that is collected for specific modes. This makes modal analysis and trending very easy further downstream using the resulting CSV files. The grid response detection element has a number of settings as well. We have our parameter range and frequency range, as well as our parameter and frequency bins. This tells DX how you would like to set up the grid in which the grid response detection element will collect peaks. This also has an EO tolerance magnitude threshold and minimum magnitude ratio for applying limit. If you have a limits file loaded, you can use limits modes here. Instead of having the frequency bins be regular intervals, this will use the mode lines as those bin limits. So it will collect a point in between each one of those mode lines and in between each one of the parameter bins. This is a very powerful feature. Finally, we have the EO response detection. This, as with the other ones, has a frequency and parameter range that you can set in which to collect peaks. I have set my number of peaks to collect to 5 here. You can also use limit modes in this mode as well to collect a peak every time a mode line intersects with a engine order that you have selected. You can set a range of IEOs or set to only collect for specific EOs as well. You can select to collect additional non-integral peaks, set your EO tolerance magnitude threshold and minimum magnitude ratio for applying limits, as those settings are available to all of the response detection elements. Again, these are very powerful features. We encourage you to reach out if you have any further questions on operating these and some best practices. We would be happy to help. Go to our user site and submit a ticket or contact us at info@apexturbine.com.